Hello everyone, this is Mohammed Yaqub. I'm back again making another STM32 tutorial after a very long time. Has been an exciting year for me. Started setting up my own embedded programming company, but here I am. I'm back again and committed to making a lot more STM32 tutorial videos. So make sure you stick around. And today's tutorial is going to be exceptional. It's going to be about the NRF24 Nordic radio transceiver, everybody's favorite. And I created a library for it ages ago, and I am going to share it with you today. I'm going to show you how to use the library, how to include it to your project, and how to use the different radio modes on the NRF. And now let me briefly show you how the library looks like before we get into CubeMX. So here's the library H file that has got all the variable definitions and function prototypes. And this is the library C file with the library variables and function definitions that shows how the functions are implemented. And I'm certainly going to include this down in my description for you to make use of it. Okay, now let's move to CubeMX and set up our project. So first click on New Project. On my transmitter side, I'll be using the Nucleo F4 board. And I think on the receiver, I'll use the F7 board. But it doesn't really matter, you can use any board you want. As long as you set them up correctly on CubeMX. So for my board, I'll go to the board selector, and it's a Nucleo 64 pins, and it's the F401RE. And the first thing we'll do here is that we're going to clear all the pins. And first thing we need to enable is an SPI line for the NRF communication. So I'm going to enable SPI1 and set it to full duplex master mode. And this got mapped out to PA5, 6, and 7. And those are the following on the Nucleo board. Those are PA5, 6, and 7, which correspond to D11, 12, and 13 on the Arduino Shield, or just a normal STM connector. The next thing we need to do is that we need to enable two digital outputs for the chip select and chip enable pins of the NRF, so the CSN and the CE pin. And for those, I'll be using PA2 and PA3. I need to set those as TPIO output. And let me also label them. So PA2 gonna go for my CSN pin, and PA3 for my CE pin. And one more thing I'd like to do as well before generating the CubeMX project is that I'd like to enable the user push button on the Nucleo board, which is connected to PC13. So I need to set this as TPIO input, and that's it. And just to clarify on the PA2 and PA3 pins, these are connected, these are mapped out to these two pins at the bottom left of the Nucleo pinout, so PA2 and PA3. Just for someone, if someone is going to use this particular board, it can be tricky to find the pins, but these they are PA2 and PA3. Alright, now let's go to clock configuration, and most probably I'll leave those as default. I don't think I'll change any of them. It's taken a while to open that window. Here they are. I'll leave it as the maximum clock speed 84 megahertz with the internal oscillator. And now on configuration, go to SPI, and we're going to change the baud rate. I'm going to change the baud rate prescaler to 32 just to make sure that the SPI clock speed doesn't exceed 2 megahertz. Okay. And that's all we need to do on the SPI configurations. So click OK, and now we're ready to generate the project. So click on generate source code icon. First we need to give the project a name. I'm going to call it NRF24 tutorial TX, and select a location to store your project folders in, and select the right IDE. So mine is MDK ARM v5, Keil Microvision 5, and click OK. And while this is loading, for any of my business contacts, you can contact me directly through Mutex Embedded Solutions, my own company's website. More on that later. Right, let's just wait for the libraries to finish. Okay, code is generated successfully. Click on Open Project, and this will take you to your IDE. Okay, and on Keil Microvision, I'll first open my main file, and I'll compile the code just to make sure everything is okay. And while this is compiling, what we also need to do is that we need to copy the library files to our project location. So these are the three library files that I'm going to include down in the description for you to be able to use the library. So I need to copy those into my new project folder, and I'm going to put them in the MDK ARM folder, the three of them, the 2H and the C file, and we're going to include them in the Keil project here. But let's just wait for this to finish compiling. Okay, it just did, so no errors and no warning, perfect. The next thing we need to do is that we need to include the library files to the project. So we copied them to the folder, but we haven't included them in the project. And to do that, right click on the application user folder and add existing files to group. And now we're going to select the C file for the library, which is the mynrf mynrf24.c. And to include the library header files, we need to go to options for target, C++ or CC++, whatever, and go to include paths, create a new path, and this we want to make the path to the MDK ARM folder. Right, taking a while. Here they are. So this is our project file system. So I want to add a path to the MDK ARM folder and click OK. And now our the NRF library should have been included to our Keil project. Okay, now let's open the library C file and right click on the header file and open the library H file too. And we're going to make a little change here just to make sure we included the right STM file. So here, this one, the first include or the first header is the STM header, and we want to make sure this is the right one. Since we're using an F4 board, so replace the 7 with 4, and if you're using an F1 board, just write 1 in here and so on. So, well, in fact, you'll find the STM header in your main, so just copy it and paste it over to here. So in my main, I can see that it's an F4 board, so I'm going to copy this and replace this one with whatever one I have on my main. And let's include the library header file into our main too and compile the code. So I need to add it in the user code begin includes. So let me compile the code now, compile the project and make sure everything is okay. All right, I have 4 errors. I think I know why. It's because in the NRF library there are functions that uses UART for printing debugging data to terminals. So what I need to do is that we need to get back to CubeMX and quickly add a UART for debugging the NRF library. And for my new Keil board, I have a UART2 on pin PA2 and PA3 connected to the virtual COM port of the ST-Link connector. So what I'll do is I'm going to go back quickly to my CubeMX. I'm going to change PA2 and PA3. I have already used PA2 and PA3 for my CE and CSN pin, but that's fine. I'm going to go them back to reset state. I'm going to connect the CE and CSN to other pins. So what I need to do for UART, I'm going to go to UART2 and enable asynchronous mode. And sure enough, those go to PA2 and PA3 pins. And now for the CSN and CE, I'm going to connect them to PP8 and PP9. Just a quick note on here. The library is designed so that CE and CSN pins has to be at the same port. So at the same PP or PC, whatever you want to choose, but both has to be at the same port for a reason that I'm going to show you later. So I'm going to use PP8 and PP9 for them. So let me connect them really quickly and get back to you. And here we are. So CSN pin and CE pin on PP8 and PP9. And now let's just quickly have a look at the UART configuration just to check the baud rate. And it's 115-200. So just keep that in mind when you open the terminal later on. Alright, now just close Keil project just to make sure it doesn't crash when we update it, and click on the update button again. I know I might have created this a bit longer, but that's fine. I do this on purpose just for you not to make the common mistakes. Code is generated, click on open project. Back on the Keil project, now let's compile it again and hopefully we're not going to get any errors now. Okay, perfect, we've got no errors. We've got 2 warnings though, but that's fine, they're insignificant. And now we're ready to use the NRF library. So the first thing we need to do is that we need to call the begin function into our main. and this will initialize the NRF library and set our pins. So the first parameter this function takes is the CE and CSN port, and that's why they need to be at the same port. So they are on, so let's say CE pin port or CSN port, the same one. And now CSN, the next parameter is the CSN pin number. So I gave it a label, that's why it appears automatically in here, CSN pin and the CE pin. But in case you haven't given it a label, you can manually pass the pin number. So for the, let me do this, for the CE pin, it's on PP9, so just write TPIO pin 9, okay? And just to make it easier to follow for you, in case you haven't given any pin a label, so for the port, you can just write the port as it is, so TPIOP, as simple as this. Now the begin function has got more parameters to take. It also takes the SPI handle. You just need to pass the SPI. So because I enable SPI1 for the NRF, I need to pass it to the begin of the library just to tell it we're going to be using this SPI line. Okay, and that's it for the begin function. The next function we're going to call is the UART debug initialize. So this is, we've got debugging functions that print data to terminal using UART. So we need to initialize the UART line too. And it's the debug UART init. Because I'm going to be using it in this demonstration, so I need to call it in the main to initialize the UART line. And we enabled UART2 for it, so I need to pass UART2 handle as a parameter to this function. Alright, and now we're ready to use the library. So now the next function I want to call is the print radio settings. This is a debugging function that will print the current radio settings, the default settings, to a terminal, to UART terminal, just to make sure the device is connected and working and ready to be used. So if this printed the correct settings of the NRF, then we know the device is connected and ready to be used. So let me show you how that looks. So let me compile the code and upload it to the board, and I'm going to show you how this looks on a UART terminal. Just connected my Nucleo board. Now let's load it to the board, and we're going to have a look at the serial terminal and see how that looks. So I'm going to open real term. Here is real term. I'll see the available ports is on port 15, my Nucleo ST-Link virtual COM port. And if you can recall from the CubeMX setting, our UART2 baud rate is 115200, and I'll click open. And I'll click the reset button on my Nucleo board, and I'll expect the radio settings to be printed out here. And here they are, perfect. So I can see all of the default settings of my radio device, for example, the TX default address. And if you look at the NRF datasheet, you'll find that indeed those are the default settings, such as the TX address. Alright, and now we're ready to begin our NRF transmitting. So now let me show you the most basic NRF transmit mode. It's the transmit with no acknowledgement, it's called. So this one will transmit regardless if there's any receiver or not, it's just going to transmit the data anyway. And to do that, the first function we need to call here is the open writing pipe. So we're going to open a pipe for writing data. And this function takes a single parameter. It takes the writing pipe address. And the pipe address is 5 bytes wide. So we're going to define an unsigned 64-bit variable. I'm going to call it TX pipe address. And I'll set the address to 11223344 and AA in hex. I'm going to pass this as a parameter to my open writing pipe function. And next thing to do is to disable auto acknowledgement. So there's a function called set auto acknowledge. That's the one. I'm going to call it down here, and I'll set the parameter to false. It's a Boolean input parameter to this function, and this will disable auto acknowledgement mode. And then we need to set the channel that data will be transmitted over. Channel is between 0 and 127, and here's a function that sets the channel. I'm going to call it down here, and I'll use channel 52 perhaps. And one more function to call beforehand, it's the stop listening, just in case we were on receive mode before we started the transmit mode. It's a good practice to call this, and then we are ready to use TX mode and transmit data.
And to transmit radio data, we need to call NRF write function to transmit data. So I'm going to call it in the main. So I'm going to write data every second by a delay. So I'm going to transmit data in without acknowledgement mode every second, and this function takes the data and the width of the data. So let me define a radio data here, something like hello world perhaps. Okay, I called it my TX data and I'm transmitting hello world. So let me pass this as a parameter to the function, and the size is 32 bytes because the NRF maximum payload width is 32 bytes, and in my begin function I set it to the maximum. And in fact you can change this, but I always like to transmit with the maximum width. So you can call it in the main somewhere in here to set your payload size, but I like to keep it on the maximum. Although I'm transmitting only the hello world, but I'm sending 32 bytes at a time. Okay, and I want to check if this is successful. So if this is equal to 1, and when the transmission is successful, I want to print something to the terminal, something like transmitted successfully perhaps. And the code looks like this. So just a normal UART transmit, and I'm transmitting this text, this size, and 10 milliseconds timeout. Okay, so let me compile the code, load it to the board, and we're gonna have a look at the terminal. Okay, compiled without any errors. Now let's load it to the board, and let's go to real time. I'm gonna open real time, and let me restart the Nucleo, and here we go. Transmitted successfully all the times. That's perfect. And if you're wondering what are the other stuff that got printed to the terminal, these are just the config and status register printed by the write function for debugging. But you can disable those if you don't want to. So just go to the definition of the write function, and you see this print config and print status register. Just comment them out, and you won't see this printed to the terminal anymore. But yeah, that's the way to transmit data without auto acknowledgement. And now let me set up the receiver project and receiver code very quickly, and we'll get back to the same stage and I'll show you how to set a receiver NRF. Alright, just created the receive STM project, the NRF receive project, but this one using my STM32F4 board. So I had to go to the head file and change the STM header to F7. Okay, just like what I have in my main. And I called the begin and the debug UART initialize functions and print radio settings. So I'm ready to just test my connections, and then ready to use it as a receive. So, but first, because I'm connecting two ST-Link devices to the same PC, I'm going to make sure that I'm connecting to the correct one. So I'm going to disconnect my F7 for now, and look at the available ST-Link devices, and we only have a single one, the one ending with 549, and this belongs to my Nucleo. So I'll cancel and reconnect my F7 again, go to settings, and now I see another device. So this one is the one that belongs to my F7. So click OK and load to the board. And now let's open a CL terminal for the receiver STM. So I open another real-time window, and I know the COM port is 6 for my receiver STM, and the baud rate I set it on CubeMX at 115200, and I click open. And now let me reset my receiver STM, which is the F7, and hopefully I'll get the correct radio settings. And here we are. So this is working as well. So this is the default radio setting for my receiver, exactly similar to this, connected successfully. Now I can use it as a receiver. So to use it as a receiver, I need to copy some of the same settings from the transmit code, which are the auto acknowledge, the payload size, and the channel number. So I'm just going to copy them over as simple as this to here to keep the same settings. And now, instead of calling open writing pipe, now we're going to open a reading pipe on the receive side, but with the same pipe address. So let's go to the receive side. We need to call a function called open reading pipe. It will ask you for the pipe number, so let's say pipe number 1, and the address needs to be similar to the TX pipe address, which is also 5 bytes. So I'm going to define it at the top as an unsigned 64-bit, and I call it RX byte address, and it's exactly similar to the TX byte address. I'm going to pass it to the open reading pipe function. And I now need to call start listening function to start listening for incoming traffic. So I'm going to call it down here, and now we can just check if there are available data and read them. And to check for available data to be received, we call NRF available in our while loop, and we're going to check for it. So if NRF available is equal to 1, then we have got data ready to be read. So we can call our NRF read data inside. So NRF read data, it takes a buffer to read the data to, and the size of the data. So unsigned integer, well, let's say character my RX data of size, let's say I'll give it 50 just in case, I might use it for debugging, and I'll pass it to the function. And the function expects a void pointer, so anything can be okay, and then the size 32 bytes. And now I'll simply print any data I receive over to the debugging UART terminal with a code that looks something like this. So I'll terminate it with a carriage return, and then I'll send it and print it over the UART terminal. Okay, so let me compile the code now and load it to the receiver STM. I'm also going to update the loading of the nuclear STM. Okay, good, and let's go to the term terminal for the both transmitter and receiver. The transmitter on the nuclear side is on COM port 15 and the receiver on COM port 6. So let me reset both of them. This is the transmitter and the receiver. Perfect. Oh, yeah, I already can see that my data on the receiver side. This one is sending hello world, and I'm receiving them on the receiver STM. And that's how you transmit and receive data without auto acknowledgement. And now let me show you how to enable auto acknowledgement. And in auto acknowledgement mode, transmitter will transmit the packet and will wait for a receiver to receive it and send an ACK packet. Then it will assume that it's transmitted successfully. And to enable the auto acknowledgement mode, all you need to do is to set the auto acknowledgement on the receiver and transmitter side to true. And let me do that for the transmitter too. And this will automatically enable the auto acknowledgement. Everything is handled in hardware level, so you don't need to do anything of that sort. So let me compile and upload the codes again. And now back to UART terminal for both TX and RX. So let me open the nucleo, TX, real term, and this one. And sure enough, data are transmitted and received successfully with the auto acknowledgement mode. But now, however, when I disconnect my receiver STM and receiver NRF, you see that transmit successfully will no more work. So as you can see, and now when I reconnect it again, it shall start again. And there we go. Okay, I've shown you how to use no acknowledge mode and auto acknowledge mode with the NRF24. Now there is one last mode that I want to show you today before I end my video, and that's the acknowledge payload. So instead of just acknowledging, it's part of the auto acknowledge mode, by the way. So with this acknowledge payload, and instead of just acknowledging with an acknowledge payload without any data in it, now this one sends data back to the transmitter as an acknowledge flag. Let me show you how it's done. So first thing we need to do is we need to enable something called dynamic payload and acknowledge payload with a function. And these are the two functions. You'll find them in the library. Let me just copy them over here. Enable dynamic payloads and enable acknowledge payload. And we need to copy them to both the TX and RX side. But on the RX side, they need to be done before we start listening. So somewhere before the start listening function is called. Starting with the receive side, whenever we read any data, whenever there is an available data and we read it, we need to send back our acknowledge payload. And we need to call a function that is called write acknowledge payload, and this takes 3 parameters. So we call it straight after we read the data, just so that we can acknowledge to the transmitter. And this takes 3 parameters. First one is the pipe, the receive pipe number, and we're using pipe 1, so just write 1 in here. And then the acknowledge data that you want to send and their size. So I'll define a variable for the acknowledge data at the top here,
I'll call it my acknowledge data or payload, and I'll send back to the transmitter ACK by STM32F4. So that's going to go as a parameter to the function, and the size is 32 bytes. So I always use the maximum size available just to avoid the complication of having a static size. Okay, so that's on the RX side. And on the transmit side, whenever we have a successful write and a successful acknowledge, we expect some data to be received in the RX50, and this is the and those are the acknowledge payload data. So we need to perform a read operation. So we need to call our normal data read function as soon as we write a data, and we need to define a variable to store the acknowledge payload data on the transmit side. So I'm going to define this at the top here globally. It's an array of a character array of 32 bytes, and we need to call it as a parameter to the read function with a size of 32 bytes. And then we'll print the read acknowledge payload to the UART terminal of the TX side, and it looks something like this. And now let's compile both codes and upload them to the board, and we're going to have a look at the UART terminals for each of the transmit and RX side. Okay, here is the terminal, so let me reset both of them. Right, and here we go. So as you can see, transmitted successfully. This one, the receiver received the hello world and sent back ACK by STM32F4. So this is the acknowledge payload mode is working too. And this brings me to the end of my tutorial today. Thanks for watching, and if you found it helpful, don't forget to hit like and subscribe. And as I mentioned earlier in the video, for any of my business contact, you can contact me directly through my company's website, mutexembedded.com. Thanks for watching, and I'll see you in the next video.